Hey Paul, hey, thanks for taking interest in my SolidWorks World presentation. Thought I'd give you a little bit of a tour. You asked a couple different questions, like how the sketch blocks terminate the end of the Weldment Structural Members and the coordinated hole locations. And I'll go ahead and show that to you, and I'll try to be brief here. So I gave this presentation for the first time last year, and I presented this at a couple different users group meetings and a technical summit run by one of our VARs. And kind of polished it up a little bit, so I think this presentation is going to be a little bit smoother than last year. I presented it again for the first time last year. But let me show you this a little bit. And what I did is I put together a power line tower as an example. This is kind of an extension of a project I did a few years ago for a client who wanted to automate his little structure he's putting together. He wanted to be able to change a couple different dimensions in order to get the assembly to change. And I thought about that. We use sketches in order to define what parts are ultimately going to be shaped like and what they're going to look like. So why not use the same concept to have a very general sketch that defines the basic size and shape of an assembly. And that's kind of what we're doing here too. So I have the top of the tower, and then I have the bottom of the tower. The bottom of the tower, each one of these legs in the bottom of the tower is the same part with the same structural members in here. It's just that the legs vary by distance. But let me go ahead and open up one of these legs, and I'll show you a little bit more in detail how we terminate some of this. So visually, right away, you can see there's these pink lines in here. These pink lines define some of the sketch blocks are in here. And you can see the sketch blocks in here. Some are in the front, some are in the back. I have a kind of a washer back here to kind of put this together. But the premise here is that all these items are going to be stacked on top of each other. Unlike typical Weldment applications, where you have a 3D sketch in the background, which we have here too, defining where a lot of these structural members are going to terminate and add a node where things are going to be trimmed and then welded. Using this for a bolted structure takes a little bit different course. What we're going to be doing is we're going to be stacking these things. So the first thing we're going to do is we're going to put in the main tower leg in here. I'm going to take my rollback bar and roll that back. So we start with this. You can see the 3D sketch in the background. And then from that, we're going to add some additional elements in here. We're going to put in our support leg in here. And you can see with this connection plate in the bottom that everything is kind of stacked. This goes first. This is right on top of the 3D sketch. This can't be on top of that 3D sketch just because of the way we have this designed and because the 3D sketch is at a little bit of an angle. So we're not using the 3D sketch but once in a very direct way. So this main tower leg is actually right on top of that 3D sketch. That defines that Weldment structural member path segment. But this one's a little bit different. It's really close to that 3D sketch line that's sitting in the background, but it's not really quite right on top of it. And you can see the difference in here if you look at that really close. And that's just because of that angle involved. So the further away you get from this line over here, the more of a distance difference you're going to get there. So that kind of defines that a little bit different from typical Weldment applications where things are all on that 3D sketch and they all terminate at a single node. Our 3D sketch is going to drive the model in a very basic way. It just drives the basic size and shape of the model. And then after that, the elements we put in here, like the horizontals and diagonals, are going to have less and less of a relationship with that 3D sketch. So let's go ahead and roll this down. In fact, let's go ahead and roll that down a little bit more so we can get some of the horizontals and diagonals in here. So the first thing we're going to be putting in here are going to be our horizontals. You can see the sketch that drives that. And if we were to right-click on that sketch and maybe open that up, you can see what that does. So we have some dimensions in here. So you have your path segment sketch in here. I deliberately made it so it kind of like terminates out here in the middle of nowhere. Then we create a block in here with reference geometry on that. And we take that block as a way to define where the termination of the Weldment path segment, the Weldment structural member path segment is going to be. So it's a 1/4 inch from on the bottom of that 3D sketch line, so it's got a relationship to it, it's parallel to it, can't be right on top of it. But we put that 1/4 inch dimension on it, it's kind of arbitrary. You could have that a little bit to the top of that or a little bit to the bottom. And then we have a 1/4 inch offset between the main tower leg and where that structural member is going to terminate. So it's right on the edge from where that fillet is. So that fillet, we don't want that structural member jamming in there on that fillet because then you'll never get it stacked in here. It'll always be off just a little bit. Now we have our reference geometry in here. We have a line that goes right down the middle of our sketch block. We have a number in here, and that line in that sketch block defines where that hole wizard hole location is going to be. That's going to be 1.5 inches from the very edge. This point over here defines where that second hole wizard hole location is going to be, like in connection plates. And then this also defines the width of that, so it gives you a visual confirmation right away that you have the correct structural member size in here. You know, the sketch block goes in first. 1.5 implies it's going to be 1.5 inches. So if your structural member is bigger or smaller than that, you know right away that you have an error in there. You can go ahead and make that change. So that's how the end of that is defined. And it's defined on the other end too in a very similar way. So the coordinated hole locations, with regard to that, if we were to take the rollback bar and roll that all the way down to the bottom, right-click on this, we'll go to roll to end. Now you can see we have those hole wizard hole locations in here. And we have a lot of stuff stacked in here. So in this item over here, we have 3 things stacked. We have our 1.5 inch horizontal, 2.5 inch or 2 inch diagonal in here, and a shared hole location. So it's like perfect every time. This is also stacked on top of that support leg that we have in here. And you also notice in here with that support leg, or that diagonal that we have in here, that it only has a peripheral relationship with that 3D sketch, which is in the background. So the pink sketches define the pass segments in here, and the gray sketch in the background is our 3D sketch. So you can see it actually crosses right there in the middle when we take a look at that. And that's because with this horizontal that we have in here, that defines where that hole is going to be, and all we have to do is plop that diagonal in the sketch block that's driving that right on top of that point that's already been established. So there's no dimensions on this one. It's just defined by the endpoint over here. You want to make sure you have your sketch block on the right side of that pass segment line. And one other advantage of this too is that when you click on that line, that pass segment line, and move that a little bit, kind of gives you dimensions that you could use. And we could take that dimension and actually make changes to it. In this one, we're going to go ahead and bring that down. So we're going to make that 5 inches down here. And you'll notice that when we do that, everything else kind of changes with that too. So we have our connection plates, they move down. You know, the horizontal moves down. All the related structural members related with this pass segment sketch line gets updated too at the very same time, which is kind of fun. So everything gets updated, and everything that's related to that gets updated with that too. So if I do Control-Z, you'll watch that that'll pop back up and go back where it was before. You can see everything that's related to it moves around too. So another advantage of this using Weldments is you get a cut list up here. Works the same as with a regular Weldment application, where you get your cut lists and all the different cuts and lengths and stuff like that, and the hole locations are all defined for you in that cut list. And you could export that out into another part drawing if you want to do that. You get the bill of materials and send that to the machine shop and have them build that. You should be able to construct your tower with a great deal of accuracy. So that's kind of the SolidWorks World presentation in a nutshell. There's a lot more to this, and I'm not going to have the time to actually show how to put together these connection plates, but they're all related. So, bottom line, we're using Weldment Structural Members for a bolted structure. The bolted structure is defined by elements that are actually stacked on top of each other rather than terminating at a node. And then you also have elements in here with the sketch blocks to define coordinated locations for hole wizard holes, and stacked elements that actually go on top of that too. So that's in there. And then to make quick modifications to your model, you can go to the 3D sketch, make modifications to the 3D sketch in here too. And you can go into the structural member pass segments and make modifications to those too. And the model should update relatively quickly and without error.